Hey everyone, today is day 9, Math 133, and we're going to cover the cumulative review number 2, which is going to start on page 416, 416 in your course pack. So make sure you grab that. Um, that's going to cover chapters 1 through 4. Cumulative review number 1, we are skipping over. Cumulative review number 1 covers chapters 2 and 3. And since we're skipping over it, if you want extra practice, that would be a good one to try doing. Okay. If you have questions on it, let me know. Yeah, so cumulative review 2, though, we're doing today. And we'll do cumulative review 3 in like next week. Um, so today we're on page 416, 416. Okay. If you didn't fill out the project survey yet, that's okay. You still have time. So if you go to Canvas and click on the Chapter 4 project survey, there's a link, and I'll drop the link for you in chat here. Shouldn't take very long. You just measure your forearm, measure your height, and you're done. Okay. So make sure you get that. Um, okay. Today, though, uh, Human Review number 2. Um, Also, of note, this upcoming Thursday, we're going to do that Chapter 4 Project 2, which is going to be using your arm length and your height. So make sure you get that done. And we're going to start talking about the sample midterm, and we'll talk about the actual midterm as well. So Thursday is going to be a good one to go to because, like I said, we're going to talk about the midterm. Now, the sample midterm is not the same as the midterm. The sample midterm is a worksheet, just like the cumulative review worksheet that we're going to work on today. So the sample midterm is, a good way to get ready for the midterm. Okay, midterm is going to be in a couple weeks, so right before spring break. Um, okay, so if you click on the cumulative review worksheet number 2 in Canvas, there is a link there that will take you to this list of data sets for all of our worksheets. And down here, cumulative review number 2, there's a Google Sheet that we'll need, but I'll drop that in the chat for you so you don't have to go search for it. But it's this one. Okay, so we'll need that in a little bit. Okay, but for now, we're going to start on page 416. Okay. And just like any of our other worksheets, we'll start by going through, give you some hints, and uh, we'll stop the recording. We'll go back through and fill out all the rest of it. Okay. All right. So, following graph shows the rate of cremation in the U.S., which is the percent of bodies cremated. Okay. What type of graph is this? What do you think, everybody? Raya says time series. I agree. This is a time series graph. Yep. And we can tell because our x-axis here is time. It's in years. It could be weeks, could be months, days, but here it's years. Um, in 2001, what was the approximate cremation rate in the US? Here's 2001 right here, and our dot is right here. So it's not 25%. 25 is this line here. Like, we're not going to get the exact one. It's approximate, but we can get more accurate than 25. We can tell that that dot is not on the line. So it's somewhere between 25 and 30. And I can tell that it's a little less than half in between 25 and 30. So I would accept 26 or 27. So Isaiah wants 27. Gabby says 26. Either one is fine. We'll 27. Is that exact? No, it's approximate, but we can get more accurate than just 25. All right. Um, in the US, the two main ways of dealing with dead bodies are cremation and burial. Two main ways. What are the other ways? Well, I guess there's donate your body to science, I guess. I don't know. In 2001, what was the approximate burial rate in the US? So cremation rate was 27, Viking funeral, mummification. It's got some good ideas. Um, what's the answer for C? So if the cremation rate was 27, what's the burial rate? And if we say there's two main ways, so if there were only two ways, cremation and burial, what would be our number here? 73. You got it, Nathan. Right? Because this adds up to 100%. So, okay. Uh, yeah, I don't know what the other ways are, but they're probably pretty small. So probably less than a percent. Okay, so we'll come back and we'll finish filling out the rest of that in a little bit. I want to jump to page 417. In 2018, the CDC published a report about binge drinking among people in the US. Following frequency distribution shows a sample of binge drinkers based on doctor and hospital records by income level. Okay, so we said that there was a link, and I dropped in the chat that'll bring you here, and we can calculate some of our things we've done before. So class midpoints. So we start with the foundational midpoint. Oh, well, no, we start with file, make a copy, right? Now, we're not actually going to turn this one in, so you don't have to rename it. Because this one is not a project. We're just going to do it and then fill in the answers on our paper. Okay. Okay, so our foundational midpoint, we're going to do equals, open parenthesis, and we'll do the lower limit plus the next lower limit, close our parenthesis, and divide by 2. So I've seen some people trying to use the upper limit. That's not what we do. We use the lower limit and the next lower limit. Okay. Get our midpoints. Now, the next thing we do is we can take this plus the class width. And I didn't actually calculate the class width here. I don't actually need to calculate the class width. I mean, I guess I do for part B. But when you're doing these projects, like you don't actually have to fill out uh enter the class width if you can calculate it. So it's 25,000 minus 0, which is 25,000. So that's our class width. And we'll copy that formula down. Okay. For relative frequency, it is the frequency divided by the total. So we need to get the total. Now, again, I don't have to type out like what the total is and calculate it. Okay. I can instead just, figure out what the total is and use it in my relative frequency formula. Oh, Gabby has a hand up. Go ahead, Gabby.
Yeah, I just I got a false on the first one. I think I typed it in wrong
Hmm.
because I'm going as you're
You're
going.
you're typing it in and it's like, nope, false. You did.
Yeah.
Um, so the formula that I have is equals open parentheses 0 plus 25,000, close my parentheses, divide by 2.
Okay, that's what I
Right.
forgot. The divided by two.
Okay. All right, so for the relative frequency, I need to know what my total is. So actually, so if you highlight column C, in the lower right-hand corner, Google Sheets will actually sum it up for you. So it's 34,897, 34,897, okay? So that's what I'm going to divide by. I don't actually have to, calculate it because I just need to put it in here. It's the frequency divided by 34,897. Okay. And if you need to shift your decimals up or down, make sure you do that. Okay. Cumulative frequency is two steps. The first one is I just copy the previous frequency, but instead of typing 7072, I'm going to do equals and click on the cell for 7072. Nope, that's not what I want. Because that's going to make it easier when I do column F. So next thing I do is I click the previous cumulative frequency plus this row's frequency, and that gives me that. I'll copy that down. And my last number should always match my total, 34,897. That's what I was using for my total. And since all of these are formulas, I can just copy this formula over and into my column F. So my first frequency should match my relative frequency. Last cumulative relative frequency should be 1.0. So there's my numbers, okay? So you'll want to, start entering those on page 417. So 12,500, right? 0.2, what was it? 0.3. Yeah, so 34,897. So fill in, all of that. Okay. Now, so I didn't actually calculate the down here. I didn't calculate the total and the class width. Okay, which is fine. I didn't. You don't necessarily need to. But what I wanted to show you though is, so when you're setting up your formulas and stuff, if this is a table that I'm going to use more than once, I want to use formulas if I can. So right here, this is my frequency right now, but next year it's going to be a different number. Okay. So instead of doing it this way, what I could have done is I could have put my formula right here and said, all right, I want you to just calculate the sum of column C. It didn't change my numbers because that sum is still 34,897. But now when my frequencies change, let's say this is only 770 next time, it'll actually recalculate everything for me. Okay. So I just put the sum in the calculation. Another thing to point out for this, so David, or sorry, Nathan is asking, oh, you got it. Okay, good. So another thing is when I'm sending this report over to someone, uh, anytime I have a number that's over 1,000, I'm going to want commas, comma separators. It makes it easier to read. So, for example, if I'm looking at this, is this 50,000 or 5,000 or is it 500,000? Like, I guess I could count the zeros, but that's just super annoying, right? So what I can do is I can go to Format, Number, okay, and I'll do custom number format. And so if I select the comma right here, it'll make it so that I have commas in my midpoints, okay? And I'll actually do that for my frequencies and my cumulative frequencies as well, so that they're easier to read. Yeah, because now it's easier to tell, oh, this is 87,500 because you can see the comma, okay? I guess I did forget to add in my chart, so insert my chart here. Because they're probably going to need to know there's only 4 bars, right? Because there's only 4 rows. So uh probably it's going to ask if we're skewed left or skewed right at some point. Yeah. But anyway, so when you are building your reports, you want to try to make it easy for yourself in case you need to use that report again. But also, as a data analyst, your job is to make sure, as a statistician, your job is to make sure that, these numbers are easy to read. So, am I going to mark you off if you don't put a comma here for the 12,500? No, I'm not. So you can write, you don't have to put the comma. Okay. All right. Anyway, so make sure you get all those filled in. Okay, so Nathan's question is answered. Gabby, you still have your hand up. Do you have another question? Oh, she's good. Okay.
I just forgot to lower it.
Yeah, that's okay. Yeah. If we were in a normal class, you probably wouldn't sit there with your hand up all class. So, okay. So we'll skip through some of this. So, part B, find find these values. So second class upper limit. What's the second class's upper limit? So 4999. Is it is it four nines or three? Yeah, so this is again why I would rather have commas here. If I had a comma, I'd be able to say, okay, I stop here. I've written enough nines. Fourth class's lower limit is what? 75,000. Okay. Class width we calculated earlier, that's 25,000. All right, modal class. So what's the modal class here? You look at the frequencies, you find the one that's the biggest, and then you write down the class name of that. So what's the modal class? It's the fourth. Yes, 75,000 or more, which is a problem. Okay, so I'll explain that in a second. So, uh, all right, shape of this distribution. What's the shape of this distribution? What do you guys think? Skew left, skew right, or symmetric? I got a right and a left. Someone needs to break the tie. Skew left, yeah. So we got this big bar right here. We got this, I guess this, it doesn't really look like a tail, but I guess we'll call this the tail, and the tail is to the left. So we're going to say skew left. But they didn't give us skewed left. They gave us negative, symmetric, or positive. So you'll remember that if you have an x-axis, positive numbers are on the right, and we put negative numbers on the left. So it is skewed negative. Now, I said a second ago that this is a problem. When your modal class is one of these buckets that you've just lumped everything together, that's no good. Okay. Um, so when you're creating your histogram, when you're creating your buckets, your classes, whatever you want to call these, your groups, you have to deal with outliers, right? This is annual income, so there's probably some people that make like $1 million a year, or 2 million, or $1 billion a year. Those are outliers, and you don't want to have like the class width is 25,000. You don't want to keep going 25,000 at a time and go all the way out to 1 billion. You're going to have a ton of rows, and a lot of them are going to be blank just for that one outlier. So when your frequencies start getting small, often what you'll do is you'll just say, okay, we'll stop there and we'll lump all the rest of it together. Okay. Um, so that's fine, as long as that's not your modal class. When this is your mode, you can get a lot more information about your graph and about your histogram if we had kept going with a couple more classes here. Okay. Um, because so what happened is we said a second ago that this graph is skewed left. It is not. Okay, because what's happening is this is actually skewed right, and they took the tail, this long tail that's supposed to be extending out to the right, and they all just lumped it into this one bar at the end and said, we'll put everybody who makes 75,000 or more into this one bar. Okay. And so there's actually supposed to be like maybe four or five or maybe 10 more bars that are getting smaller. You can actually see it happening. This first and second bar are kind of large, and then this third bar starts to go down. If we had kept going with our widths at 25,000 and not just lumped it all together, this next bar probably would have been right like this high, and the next one would have been this high, and so on. And so once you get out a little farther and you have your numbers starting to go down, then it's okay to lump them together. Okay. But if you lump them too soon, you get a problem where you have actually uh, screwed up what the shape actually is supposed to be. Okay. So anyway, regardless, we'll leave it at skewed negative, even though that's not what it should have been. Whatever. Annual income level is a qualitative, quantitative, discrete, or quantitative continuous. Gabby says it's quantitative discrete. Mary says continuous. I need a tiebreaker. Kelly says continuous. So are we allowed to have decimals when we're looking at income? Yes, we are. You can actually see that there's decimals in there. Uh, so someone can make $74,999 and 93 cents, right? That's fine. Okay, let's skip those ones. Um, this one, find the mean and the standard deviation. So page 254, we had three methods on calculating standard deviation. And for this particular problem, we're using method 2. Method 2 is if you have a frequency distribution, and that's what we have. So we're going to do stat, summary stats, grouped bin. Okay. Interpret their value in the context of the situation. So that is going to be on page 253. We have our give or take script. Okay. All right. All right. Question number 3. The CDC analyzes the cigarette usage, which is the percent of adults who smoke, and the average life expectancy in years in all the US states in 2022. So this is a linear regression, which we'll find info on that on page 255. Okay. And so page 255, if we were doing it ourselves, it would be stat, regression, simple linear. Okay. But they've already done that for us. They've done the stat crunch and given us the result. So we're basically just going to read off of what this is. Okay. Yeah, so Gabby, I'm not sure if that is included in here or not. But yeah, so uh question A, each dot represents what? Is each dot a smoker? Yeah. Thank you, Mary. Each dot represents a state. Okay. So we look at what is our population or our sample, and in this case, they said that we're looking at all U.S. states, so there should be 50 dots. Now, I'm not going to ask you to count them, but they actually have the sample size right here for us, so there are 50. Okay. Um, explanatory variable, that is the x or the independent variable. So in this case, the x-axis is cigarette usage. Now, when you have cigarette usage, when you are looking for your explanatory variable, your x-axis, it is either going to be time, if it's a time series, or it's going to be the thing that you have more control of. So does a state have control over cigarette usage? I mean, kind of. You can raise taxes on it. You can outlaw it, right? You can't completely control it, but the y-axis is a thing that you have less control over. So the response variable in this case is life expectancy. Can a state decide, when people die or not? I mean, not really. You can you can indirectly affect that by, reducing cigarette usage or by, increasing healthcare, things like that. But that's not direct control. You are indirectly adjusting that. Okay, so that's your dependent variable. Okay. All right. So I'll skip through that. Um, interpret the coefficient of determination in the context of the situation. This is on page 255. There's a script for this at the bottom. Okay. All right, so let's do this one. Based on the correlation coefficient, describe the direction and strength of the relation. Moderate positive, strong positive, weak negative. Yeah, you guys got it. Strong negative. Thank you, everybody. Our correlation coefficient in this case is negative 0.81, and it's negative because this is a negative slope. Okay. Now that doesn't mean that it's a bad correlation. It actually means that this is actually quite a good correlation, a very predictive one, because it is strong. Negative just means that as X increases, Y goes down. If a state has a lot of cigarette usage, then that's going to hurt life expectancy. And that makes sense, right? A lot of cigarette usage is going to reduce, it's going to, cause people to have health issues. So negative 0.81 is going to land right here in the strong negative. Okay. All right. I'm not going to set that aside because I still need it for the next page, page 419. Find the slope of the regression line. That is negative 0.583, 583. Explain what it means in the context situation. That's on page 255, script in the middle. Okay. Find the y-intercept of the regression line. So that's 0, comma something, 0, comma 85.396. Okay. Explain why the y-intercept does not make sense in the context of the situation. So the script for that goes impossible for blank, and then you write out why this is impossible. Why can a state never have this? Now, usually it's because the x is 0. That's usually the problem. In this case, the y is life expectancy. Can a state have a life expectancy of 85.396 years? Yeah, it could. Okay, if you have a state where people are living in a really long time. So that's not the problem. In this case, it's the 0 is the problem. Okay. Um, I'll talk about that. This one, Michigan's actual life expectancy is this. Find the residual. Residual is at the bottom of page 255. And that is residual is the actual y minus the predicted y. Okay. And it could be negative depending on whether the dot is above or below the line. Okay. All right. Lastly, identify a potential lurking variable for this situation. So a lurking variable is what we are talking about when we are looking at correlation versus causation. Correlation is not causation because there are lurking variables such as something that are affecting variables. In other words, there when we are looking at cigarette usage by state, um, just because a state has higher cigarette usage, that's not necessarily causing lower life expectancy. Okay. There could be something else that's driving both of those. Okay. So, what would be something that could cause people to use cigarettes more and cause them to live to not live as long. So yeah, I agree. So I like your answer, Rias. Stress, right? If you're living in a state, I don't know, maybe New York, where there's a lot of stress, um, we know that stress causes people to use cigarettes more. We also know that stress leads to hypertension, less it, not sleeping as much, and it leads to lower life expectancy. So this could be a cause that we're not even looking at in this graph. That's actually what's causing both of these numbers to go up or down. Okay. So that's the kind of argument that like a tobacco industry would make where they're saying like, okay, just because you have a strong negative correlation doesn't necessarily mean that cigarettes are causing lower life expectancy. So, I mean, I disagree. I agree with that statement, but anyway, they would be able to argue that against that. So, okay, so let's stop the recording. We'll go back through and answer some of the questions we skipped over. Yeah. So any of those answers are fine, Gabby. I just put one down, so yeah.